Now we're going to be looking at the volume of composite objects. So what the word composite means is two or more objects put together. So in order to find the volume of those, we'll need to find the volume of all the objects and then add them together. So in this first try these, it says which 3D object is like the outside of this nut they gave us here. So the outside of it, well, it has 6 sides, so we know that is a hexagonal prism, right? Because if we looked at the other side of this, there would also be a hexagon on it. And remember, a prism has the shape on both ends. So this would be a hexagonal prism. And then on the inside of it, this is a hole, and it goes all the way through. So you can imagine that it would go all the way through like that. It would look something like this, which is a cylinder. So now let's look at finding the volume of these composite objects. So Jesse works at a jewelry store. One popular metal stud they sell has the dimensions shown, so over here. What is the volume of this stud to the nearest cubic millimeter? So you'll notice that this stud, it has a cone on both ends of it, and then a cylinder in the middle. So for A, let's put 2 cones, 1 cylinder. So let's start with the volume of the objects at the ends, which means the cones. So if you remember from the previous topic we did, the volume of a cone formula was the area of the base times the height divided by 3. So the base of a cone, if we draw a little cone here, the base of a cone is a circle. So the area of the base is pi r squared, which is what they have in the formula right over here. Then they have times the height divided by 3. But in this composite object, there are 2 cones. So we're going to have to find the volume of one of them and then times it by 2. So that's what this blank is for. So we're going to find the volume. I'll just put here volume of cone. And then we're timesing it by 2 because there are 2 of them on our composite object. 1, 2. So again, I'm going to write the number 2. And now we have pi, the radius of those cones. If we look, the distance all the way across they gave us is 5. That's the distance from here to here. It's kind of hard to see. I'm trying to write it on there. Here to here. So the radius would be half of that because diameter goes all the way across and radius is half. So in this blank, we're going to put 2.5. That's the radius. Then the height of the cone is going to be from here to here. That's the height. So if we're looking on our diagram, the height would be this measurement 6. So I'm going to put a 6 there. And then we're going to divide all of that by 3. So now if we plug this in our calculator, we'll do 2 times pi times 2.5 squared times 6, and that's all divided by 3. So if we put all of that in our calculator, our final answer will be 78.54 millimeters cubed. Now let's find the volume of the object in the middle. And we said the object in the middle is a cylinder. So the volume of a cylinder, remember that a cylinder is a prism. A cylinder is a prism. So the volume of any prism is just the area of the base times the height. So if we're looking at a cylinder, the base shape of a cylinder is also a circle. So if we're doing the area of the base, it'll be pi r squared because that's the area of a circle. So that's what they have here, pi r squared, and then we're going to times that by the height. So again, the radius, let's look. This time they gave us the diameter is 2. We can see right here it points to the diameter, which is 2. So we know the radius is half of that, which is 1. Then we're going to times that by the height of the entire cylinder. So that would be from here to here. and the measurement they give us for that is 12. So if we put this in our calculator, we're going to do pi times 1 squared times 12, and we get 37.699 millimeters cubed. So finally, we have to find the total volume of this metal stud. So we're going to add together all the volumes we have. So the first one, we're going to put the volume of the cones we got, which is 78.54. So 78.54 millimeters cubed, plus we're going to do the volume of that cylinder we got, which is 37.699. 37.699. So if we add those two together, the total volume is 116.238 millimeters cubed. Or if we round it, we could say the total volume is 116 millimeters cubed. In the next example, we have Carl working in a wood shop and he needs to make a wooden doorstop as shown. What is the volume of wood he needs to the nearest cubic inch? So all of our measurements are in inches, and you'll notice this time they gave us fractions in our measurements. Let's just convert those to decimals. So if we have 1 1/2 inch, that's the same as 1.5 inches. So we're going to use that number instead. That's 1 1/2. And then 3/4 inch, that's the same as 0.75 inches. And we can convert this by doing 3 divided by 4 in our calculator to get 0.75. So let's look at what 3D objects make up this doorstop. So if we were to divide it up right here, we would have a rectangular prism. So that's the part that's over here. And then in the front, we would have a triangular prism. And we know that this is a triangular prism because we can see a triangle on this side of it, and then on the other matching side there is also a triangle. So it is a prism. So let's start by finding the volume of object number 1, which we're going to consider is the rectangular prism. So this is number 1. So remember, for any prism, the volume is equal to the area of the base times the height. So when it comes to a rectangular prism, the base is the shape of a rectangle. So in order to find the area of that rectangle, we're going to have to do length times width. So that's where they come up with this length times width here, and then we have to times that by the height to get the volume. So the length times width would be, well, the length, if we match that up with a measurement, it would be the same as this side. So the length is 2, and the width is right here, which would be 1. And then the height of the whole thing would be this side right here, which would be that 0.75. So in our calculator, if we did 2 times 1 times 0.75, we're going to get 1.5 cubic inches, or inches cubed, for that volume. Next, let's find the volume of that triangular prism at the front. So again, we have to do the area of the base times the height. And this time, our base, the base is always the matching side or the matching shape of a prism. So in this case, it is a triangle. So we need to find the area of that triangle. So the area of a triangle is equal to, so I'm just going to put area of a tri is equal to 1/2 times the base times the height. So the base of this triangle is 1.5, and the height of it would be on this side, which is 0.75, because it matches this side over there. So if we're finding the volume of it, we need to find the area of the base. Now, I don't like how this booklet set up the fill in the blanks, so what I'm going to do is I'm going to scribble out this 2 down here. We're going to switch it to 1/2 out front, because that's the formula we know for area of the base, which is a triangle. And here I'll label that the triangular prism is the second one we're dealing with. So now if we're doing 1/2 times base times height, the base we determined is 1.5, and the height we determined is 0.75. So we're going to do 1/2 times 1.5 times 0.75 in our calculator. And then finally, we need to multiply that by the height of the entire prism. So remember, the height of a triangular prism would be this length right there. So that would be the height. Imagine it was sitting on this triangle on the base, and this would be the height pointing upwards towards the sky. So the height would just be 1, because that's the measurement down there. So we could skip over the step here, and in our calculators, we're going to put 1/2 times 1.5 times 0.75 times 1. We're going to put all of that into our calculator. So our final volume in inches should be 0.56 cubic inches, or inches cubed. And just a heads up, if you're ever putting 1/2 in your calculator, you can put 0.5 instead. Or you could do 1 divided by 2, which is the same thing as 1/2. So the total volume, we're going to add up the volume of object 1 and the volume of object 2. So we're going to add together 1.5 plus 0.56. So if we add up those two volumes, our final answer will be 2.06 inches cubed, or cubic inches, or 2 cubic inches to the nearest cubic inch. And for this topic, we are going to skip over example 2. So we'll just stick with those first 2 examples that we did.